This is Circus, a CS426 senior project for 2023-2024 at University of Nevada, Reno for computer science and engineering. Our team is Team 39, made of Dillon, Ainsley, and Nevan. Our instructors are Dave Felseifer, Sarah Davis, Vin Lee, Devin Lee, Zach Estriado, and our advisor is Dr. Zhenwan Park, an electrical engineering professor at UNR. We provide a comprehensive learning tool for designing, implementing, and analyzing DC circuits. We have a circuit editor that allows users to create, customize, and visualize their DC circuits. This will allow them to perform KVL, KCL, Thevenin, and Norton analysis on the circuits they have provided. And this is for students, professors, and anyone interested in learning or working with DC circuits. Python is our main programming language that we use, and LCAPI is the module that supports circuit analysis and circuit handling, while PyQt supports our graphical user interface. The features we provide are a drag and drop circuit editor, the ability to save circuits and reload the previously saved circuits. You can request component properties and perform Thevenin analysis, Norton analysis, and mesh nodal analysis. This is our live demo.
Hello everyone, my name is Nevan and I'll be demoing some of the features of our application here. So first thing I will be showing is opening files. So for our application, you want to have your circuit saved as in a plaintext file in a netlist format. So I'll show you what a netlist looks like. Let's see, over here we have some examples of netlists. Netlists are an industry standard way of expressing circuits in a text-based format. So they show every component and what nodes they're attached to. And you can also specify directionality. So we'll have two demo circuits here. We also have a circuit with some bad syntax, just to showcase what our program will do with that. So let's go back over to our program. Let's try opening some of those files. So clicking on the Open File button opens up this File Explorer menu, and you can open up your file. And then the program will load the circuit and generate an image, and it'll also give you some analysis options. So we can click on mesh analysis and it'll give us some of those mesh equations. And we can go back to click on nodal analysis to see what the nodal equations look like. You can also access those through the menu bar. And we can also open up another circuit. So let's try opening up circuit 2. And here we can see circuit 2 is generated, and we can look at those analysis expressions and equations. We are working on giving the user the ability to export these images and save them into like PDF or PNG files. And let's try seeing what happens if we open up that bad circuit. So as you can see, we get an error and it tells us that the file does not contain a netlist. So we can try opening up a different one. And that's pretty much it for loading circuits. We are still working on generating random circuits that will be quickly implemented soon. For now, I'm going to pass it over to Ainsley, who's going to showcase creating new circuits in our drag and drop feature. So just click on that button, opens up this drag and drop window, and Ainsley will showcase that now.
Alrighty, so once you click on that Create New Circuit button, you are taken to this window. It should pop up and it's your circuit editor, which has your components on your left side. So once you click on a component, it appears in the canvas on your right, where you can just drag around and connect the elements. As you can see, once the wires are connected, you can move the elements around and the wires will follow. You can create your nodes. You want to make sure you have a node in between each element for it to work properly. And you're building a proper circuit. When you do successfully build the proper circuit, you can click this Save Order button up here, and that will just save this circuit as a netlist, and you're able to reload that and use it on the other functionalities within the program. Let me just finish building this and then I'll show off some other functionality. So as you can see, the wires stay connected. Now, if you're adding on nodes here and say, okay, I have 4 and 5 node connected somewhere, but I delete my 4 node for some reason, but I still want that 4 node, I can go back. It'll just be right there ready to pop right back up onto your screen. So we're just going to get rid of those because we don't need them. Now, say we have a resistor, but we want to align it vertically. All you have to do is just right click and then you can just rotate that 90 degrees. And this works. This also works connected with the wires. You just have to move it around and then it will fix itself. As you can see, it gets a little funky when you start to do that too much, but it's no big deal. So we just put it back right there. Now say we want to add values, all you have to do is double click and you can either use the arrow keys to set your value or you can just type in to your keyboard and then set, and then there it is displayed right there for you to see. You can, once you like your circuit, you can click this save order button and it'll just prompt you. So we'll just make this a test file, save, and now if we go back, let me just show you. So you can choose where it saves, obviously, within your computer. I have it saved within all of this files, so I can just go back, pull it up, and then here is your net list, and it shows you the elements, the nodes they're connected to, the direction of the nodes, and then the value of the element. And then you can reload that into your program in order to perform the other operations needed on your circuit. One other thing I would like to point out is we had some comments saying that the nodes and and other stuff are a little hard to press on. So I added this so that when you hover over a node, it enlarges to make it just that slight bit easier in order to click on it and get what you need. So that's pretty much our circuit editor. As of now, we are working on implementing more elements and perfecting that algorithm backend in order to ensure that we are always getting a proper netlist that works with our circuit, and also to make the functionality just easier to use as a whole. Thank you.
We are also implementing requesting component and node properties. This will allow users to find specific properties on the circuit components, whether it be the resistance of a resistor or the voltage of a resistor or the current going through an independent voltage source. And this is being implemented into the graphical user interface. More continued development is for implementing Thevenin and Norton equivalents into the user interface, and then developing random circuit generation for further studying and allowing for new circuit use.